In this video demonstration, we're going to begin looking at how files can be utilized in your Java programs. Now, up until this point, you have mastered acquiring input from keyboards and sending output from your programs to monitors, to the terminal. So what we're going to look at now is this. We're going to look at how you can write output from a program that you write to a file, and then how you can load data from a file into your program for processing as well. So now, your textbook here is basically all the samples focus on Windows. Like say, for instance, in this little sample code right here, you see the C drive listed right here. Now, when we're going through this, we're going to have to modify some of these demos to work with Linux. Linux, or like Raspberry Pi, like Raspberry Pi, which is based on Linux. Linux does not utilize drive letters. So as we're going through the demos, we're going to have to be mindful in regards to accessing files using Java on Linux. So let's start here. It says files are used by many applications for storing and retrieving data. In this chapter, sequential file access, including object serialization, will be discussed. Exception handling will also be explained. We're going to be focusing in on the file portion of this, accessing files, reading files, writing to files. We're not going to worry too much about object serialization. That's beyond the scope of this class. But we're also going to take a look at exception handling as well. Now, you know that an exception is a runtime error. We're going to take a look at some code that can be written that will handle when those runtime errors occur. So typically when a runtime error occurs, your program crashes, and there's some output sent onto the terminal. We're going to take a look at the way in which exception handlers can be coded to deal with runtime crashes. So first off, what is a file? Up to this point, applications created in this text have stored data in the computer's memory. However, storage in memory is available only when the computer is on and the application is running. We call that volatile storage. You may remember from Computer Science 20. A file is a collection of related data stored on a persistent medium, such as a hard drive or a CD. Persistent means that it's going to be there for a while. So on Comp Sci 20, we talk about volatile and non-volatile storage. We'd say how RAM, which is also called the computer's main memory, is referred to as volatile storage because, by and large, data can only be stored in RAM for as long as the computer is powered. Once the machine is either restarted or shut down, whatever data that was in RAM is lost. Hence, volatile is considered volatile memory. Non-volatile storage is anything that's designed to retain data without the machine being powered. Hard drives, solid-state drives, USB thumb drives, CDs, DVDs, Blu-rays, and so on. These are all storage mechanisms that are designed to retain data while a system is no longer powered. So we're going to be taking a look at how files stored on some kind of a storage medium can be used to load in data into your programs and can be used to write outputs to a file as well. Files often store data used by an application. Files are also used to store the data generated by an application as well. In either case, a file is separate from the application accessing it and can be read from and written to by more than one application. Most applications require access to one or more files on a disk. So really, you guys have been using computers for years. When you open up an application, typically there are settings that the application will load in as the program is running. Those settings are sitting inside of a file. Like say, for instance, even like operating systems, as you configure the operating system, whether it is your screensaver, whether it's positioning of the taskbar and so on, the machine needs to remember all those settings. Now, how does it remember all that? Well, it writes that information to a file someplace on the hard drive. So those settings are saved to a file, and then when, let's say, for instance, you fire up your operating system, those settings are loaded so that your environment looks the way that it should look based upon your settings. Now, Microsoft Word is another example. You know, you're writing something in a word processor, and when you click Save, all that information has to be written to a file. Now, let's say, for instance, on one night, you're working on an essay for English, and you don't finish it, so you decide to pack it in for the night, so you quit. You wake up the next day and you decide to resume work on your essay. Well, the first thing you do after you got Word running is you do a file and open, where you are reading the data from a file. So being able to work with files in a programming language is a fundamental programming skill. So in terms of making working with files easy in the Java language, we're going to take a look at some of the file classes. The file class, part of the java.io package, so this is a new package that you guys will be working with, is used for creating an object that represents a file. A file object can be used to create a new file. It can be used to test for the existence of a file. It can even be used to delete a file. Some of the file class methods include the following. So, java.io package must be explicitly imported into your program. So whenever you want to work with files in your programs, you will need to import java.io package. There's the create new file method, which is used to create a new file on a storage medium. Creates a new file using the file name specified in the constructor. If the file does not already exist, it returns true if the file is created, and it will return false otherwise. This method throws an I/O exception, basically a runtime crash, if the file cannot be created. So let's say, for instance, how can that happen? How can it not be able to create the file? If you asked the Java to create a file in a folder that you do not have permissions to, the machine would not be able to make that folder. And then you'd get that exception thrown saying that basically you wouldn't have the rights or the permissions to create that file. Now, a good example, let's say, for instance, let's say you were coding these programs on the Windows machines in my lab, and you guys have access to an H drive. That H drive stores all of your files. Now, let's say, for instance, that you ask Java to create a folder in someone else's H drive. Now, that's not going to fly. Now, an exception will be thrown because you don't have the permissions, the required permissions, to create that file on someone else's H drive. So, create a new file. If the file already exists, so be it. It just leaves it alone. If the file doesn't exist, create a new file will then make it. And then, however, create a new file will throw an exception if you're asking it to create a file in a folder or on a drive that you don't have the necessary permissions for. There's a delete method. Got to be careful with this one. Delete is used to wipe out files, so careful, careful. And then there's the exist method, which is used in my life just sort of take a look to see if a file with a specific name already exists within a directory. The application below checks for the existence of a file. We got import java.io.wildcard. So there's the package that contains all the methods that you would like to use in regards to files. Public class test files. There's the main method. A file object is instantiated. It's identified as text file, and look at its initialization. Now, notice this is specifically for Windows. It's looking at the C drive. Now, if that file exists, if exists return true, file already exists. Now, if it doesn't exist, well then the else clause will kick in and file does not exist. The name of a file is specified as a string. If a path is included in the file name, the escape sequences must be used to separate the drive, folder, and file name. So you'll notice here the double backslash. Why the double backslash? You're getting a double backslash simply because the backslash symbol is the escape symbol, and you're asking it to escape itself so that you can actually get backslashes into this string. So we're not going to worry about my file part 1 of 2. Let's code this little test files here, and let's just experiment with looking for files or creating files on a Pi. And technically, this is actually the first time that I've done this in Ubuntu and Kali Linux a number of times. But I've never actually ran code like this on a Raspberry Pi using Rasby and Jessie. So let's give this a fly and let's just see how this is going to work on our Pis. So go to a terminal. I'm going to do a listing, cd, let's see, CSC, wildcard, listing. Okay, so here's all our stuff: arrays, control structures, Java intro, methods, and so on. Let's make a directory for files. So maker files. I'll do a listing. And I see my files directory. Let's cd our way into it. So cd files, do another listing. There's nothing in there. Let's make subdirectories for demonstrations and assignments. So make dir demo, make dir assignments. Oh, I got a typo there. Okay, you know what? I'm going to quickly, because I got a typo, I'll fix that this way. Arrays, assignments, right click, rename. All fixed up. There we go. Do another listing. There we go. CD my way into my demos. All right. So let's code this little test files here, and let's see how this is going to work inside of our Raspberry Pis. So let's go to our editors, and let's make a new file, and opening comments. We'll call this, it was called test files, I believe is what they called it. Yeah, test files. Create a program that demonstrates how to test for the existence of a file in Java. Let's save this up. Pi documents 30 files demos, and this is testfiles.java. Okay, let's import the class necessary to work with file objects. Import the class needed to instantiate file objects. Imports java.io, and we import the entire package, not just one or two classes. We import the whole thing there, so hence the wildcard to represent all the classes within that package. Documentation comment for the class. Test files class demonstrates how to test for the existence of a file in Java. Class declaration, public class test files. Main method declaration, public static void main string args. Okay, let's start off by instantiating a new file object and initializing that object with the name of a file. So as a comment, let's instantiate a file object and initialize it with a file name. Now when we look at our code here, it's accessing the hard drive. This is an absolute path starting right at the very root of the hard drive. So we're going to use, let's try using a relative path. And a relative means that instead of starting right at the roots, let's just simply specify a name, and Java will look for that file right within our demonstration folders. So let's go back into our code here, and let's go file, that's the name of the class. We're going to call it text file, is initialized with a new file. Initialized to, now this is a string, so we can close it between double quotes. And let's just simply call it supplies.text. Okay, let's save that up. So let's do a quick comparison here. In this example right here, we tell, the programmer here is telling the computer, telling Java, start the C drive, find the temp folder, and within the temp folder, look for a file called supplies.txt. Now, what we're going to try and do, what we're going to try to arrange for ourselves here, is not give an absolute path, we'll give a relative path, and see if it'll just look right within our demonstrations folder. So this is all saved up. Let's give this a quick compile to make sure that everything is fine so far. Do a listing, javac test files.java. Okay, so far so good. No compiling errors. Let's go back into our code. Now after instantiating a new text file, we are to test to see if this supplies.txt file exists inside our current folder, which is the demonstration folder. So let's go back into our code here, and let's do test to determine if the file exists within our working directory. Our working directory will be inside our demonstrations folder. So we're going to use a relative path as opposed to an absolute path. See if this works. Like I said, I haven't done this in Raspbian, so we'll see how this flies here. So let's go back into our code then. Let's perform an if text file dot exists. So if supplies.txt exists within our local demonstration or working folder here, as a comment, this would be condition where the file does exist within the working directory. So we'll go system.out.println the file exists. Okay, now else clause. What if it doesn't exist? Well, then I'll put a message onto the terminal. Condition where the file does not exist within the working directory. System.out.println the file does not exist. Okay, I'm going to save that up. And after saving that up, let's give this thing a compile. And I have a typo. System.out.println, so I'll fix that little syntax error. Save and recompile. Okay, so it compiles. Let's run it. Now right now, inside this working folder, if you make your way in there, Files, Demonstrations, that little supplies.txt, that file doesn't exist anywhere inside of our program or inside of this working directory. So let's compile Java test files. The file does not exist. Okay, that's right. That's working. Now what we should do is we should make this file and then try this again. So let's just kind of hop, skip, and jump here just for a moment. Let's skip back into our textbook file for a second. Now, if we scroll on down here, the next section talks about handling exceptions. But right here, we're going to kind of piggyback a little bit on this little sample program right here. And we are going to create a file, and then we'll test for its existence. So you can see here that in this list of methods for the file class, geez, scroll too far here, we're going to use this create new file, and we're going to use it to create that supplies.txt. Now we can see the syntax for using create new file right here in this little sample. So what we're going to do is this. Let's go back into our program. Let's create this file, and then let's test for its existence. It's only simply because we're doing this on Raspbian Jest. We just want to make sure that we can navigate the directory structure properly in order to work with files. So let's go back into our source code then. Now, put your cursor, get a couple lines right here. And after we have instantiated a file object, and we've initialized it with a file name, let's create the file within the current working directory. So the syntax was simply text file, that's the name of the object, dot create new file. Now we've already constructed text file with a file name. So when we go to invoke or call create new file from within the file class, text file has a file name, so Java will use this file name to create that new file. Okay. Let's see how well this works then. Let's save our code, And let's give it a recompile. Okay, now, all right, so now we're getting a message from the compiler stating that we cannot use create new file unless we put it into an exception handler. So I thought maybe we can kind of skip a step here, but it looks like Java is going to force us to put this inside of an exception handler to make sure that if there's any problems, the program doesn't crash. So it looks like for now is this. We're going to have to take this out. And let's do it this way. Save this, and let's make add a new or create a new file in your editor here. And we're going to simply put something in here. Hi there. And let's save this. And we're going to call this supplies. Let's go Pi documents 30 files demos. And let's call this file just simply supplies.txt. So we're going to have to do it the old school way. We'll save it. Okay, so I can see it right there. Now I'm going to go into I'm going to go right here, and I can see it. I can see supplies.txt. So it's there. All right. Now let's go back into our source code for test files. We took that statement out, so we instantiate a file object, initialize it with supplies.txt, and we know that we saw this file does not exist before we had that supplies.txt sitting inside the folder. Now that we do have a file called supplies.txt inside this folder, we want to test to see if the file exists. We want to see if we can get this message here. So supplies.txt, we have a file with that same file name inside the working directory. And we got the same file name that we used to instantiate our file object. So let's recompile our test files here. Oh, and there it is. The file exists. Okay, this is actually kind of huge. And it's kind of huge because of this. When you're coding in Java on a Windows box, by and large, you as a user have access to many of the folders within the C drive. Now, for better or worse, you do. Now, on a Linux computer or a Linux-based computer like Raspberry Pi, you don't. The permissions that are set for the user accounts on any Linux system are different than on a Windows machine. Linux, in many cases, can be considered much more secure than a Windows machine. So this is actually a major simply because in your textbook file, it's always demonstrating accessing the root drive. Now, in some cases with your accounts, you don't technically have access to the roots of Raspberry Pi on Jessie. So by not having to specify an absolute path, by us being able to specify a relative path like we're doing, just simply supplies.txt, we're forcing Java to look inside the directory that we are currently working within, in this case here, the demonstration folder. So this is looking good. Now say for instance that if I were to delete supply, you know what, I'm just going to rename it. I'm going to choose rename, and I call it supplies_new. Oh, look at that, boy, typos, wow. Rename that thing again. So I've renamed this file. So now there is no longer a supplies.txt because I haven't deleted it, I've simply renamed it. So after doing that, if I recompile and run, the file does not exist. Okay, you know what, this is looking very good. I'm going to fix that again, do a rename, supplies.txt, I will click OK, and I'll recompile, run, bingo. Okay, huge success, because this is going to allow us to work with files on a Linux-based computer much more easily. And that's the end of this video demonstration.